Hello, I'm Greg Pollock.
And I'm Jason Cipher.
And you just downloaded the first Envycast.
Congratulations.
We'll be going over advanced ActiveRecord in this screencast.
It's a very advanced tutorial, so you might want to keep your remote control handy so you can skip around, go back and forth, because you might want to replay each concept at least 2, perhaps 5 dozen times.
I don't think it's that advanced. I mean, we're looking at loading large data sets, foreign keys, using include, counter cache.
Well, that stuff is sort of basic, but after that we're going to be moving on to polymorphic associations, single table inheritance, and some new stuff in Rails 2.0.
Yeah, I guess that is more advanced. That's the sort of stuff that I always end up looking up on a weekly basis. It just doesn't stick in your long-term memory. You know, I wonder why it is that we forget that sort of stuff.
I think it's because Greg's a bit of a drinker.
Oh, hello there. I'm Dr. Pollock, and I'm here today to talk to you about how your brain works. You see, it all starts out with the neuron. We all have about 100 million neurons in our brains. That's about the same number of trees in the Amazon rainforest. Each neuron can connect to around 10,000 other neurons through what are called synapses. So the total number of connections in your brain is about the same number of leaves in the Amazon rainforest. Now that's pretty impressive. That's about 10 trillion.
Whoa, whoa, whoa. I mean, that was interesting, and those are some nice pictures and all, but why are we talking about the brain when we paid for a screencast on ActiveRecord?
Yeah, okay, well, let's get on with it. For most of this tutorial, we'll be working with a common schema, and it looks a little bit like this. We've got a typical users table, a posts table, and this is with, a blog. A user has many posts with the relationship there. Inside the user model, the user has many posts, and inside the posts model, the post belongs to user. Pretty simple.
So the first thing we're going to do is load 5 million fake users, and I wanted to figure out what the quickest way to do that was. So I started out with a test where I built an array with 10,000 fake users. I'm using the faker gem here, which gives you, a fake first name and a fake last name, and if you want, it also says like fake addresses and fake cities. So obviously the first thing you can do when you want to create 5 million fake users, or in this case 10,000, is just to do user.create, right? This was a little slow. We got for about 10,000, took about 14 seconds, which meant if I did 5 million, it was going to take 7,000 seconds, which comes out to about 2 hours. Now this is obviously slow, but it's slow for 2 reasons. The first of which is obvious, because creating objects is slow. The second, though, is because this does a transaction on each insert statement, and transactions can slow things down. So the first thing we can do to speed this up is to wrap it in a single transaction. This would take about 11 seconds to run, which comes out to about 5,500 seconds for 5 million, which is about 1.5 hours. A little quicker, but not really quick enough. So what would be our next option? Our next option would be to simply use the ActiveRecord connection to insert directly into the database, right? Now this isn't going to be using any transactions, it isn't going to be creating any new objects, just loading the SQL statements right in. Doing this would take about 2 seconds for 10,000, about 1,000 seconds for 5 million, and about 16.7 minutes. That's a lot faster. But I was looking at this and I said, there has to be a faster way. There has to be a way to do bulk insert statements, right? And to do that, I found the ActiveRecord extensions gem. With that, you simply call the user.import method with your big array, and it does these big, huge insert statements. This took about 0.44 seconds for 10K, 220 seconds for 5 million, which meant it was going to be loading in about 3.7 minutes, which is nice and fast. So this is how I ended up loading 5 million records.
Our next code challenge is going to be to print 10 posts and the author of each post. So we might create some code that looks something like this. We get all the posts and we print out the title of the post and the author of the post. Our output might look like this, and if we looked in our log file, it might look something like this. Lots of SQL statements, too many SQL statements. So how do we get around this? Well, we add an include. Right? With the include, we get the same output, and this time our SQL uses a left outer join, right? As you might expect. Our next challenge is to print a user and list their posts. Kind of the other way around in the relationship. Our code might look something like this, where we fetch a user, print out their first name, and print out all the titles. If Elena only had one title, this could be the output. And here is the SQL that goes with it. But if we take a closer look at what's going on here, it's a little slow. So Jason, why do you think this might be a little too slow?
Well, I think I could point to it with my index finger.
Oh yeah, it's the index. The index is missing. So we need to make sure we add that. And all that means is we add the add index method to our migration.
Now what's important to remember is you're going to need to add an index on any column in your database that you're either going to be joining on or querying on in your application. Keep that in mind as you build it.
Yep. So now let's go back to that original code and run it again with our foreign key and see how much it speeds it up. Well, we get the same output, and now with the foreign key, we're about 148 times faster. That's pretty big. Yeah. So a few months ago I was working on a project, and this project had many guides in it, like guides meaning, like tutorials on a certain subject. And each of those guides, people could go on and they could ask questions about the guides, other people could come on and answer the guides, and on the front page we wanted to list out all the guides and the authors, right? So we wrote an include method that looks something like this, right? The SQL that went along with it looked something like this. It was pretty big. These tables were big, so the SQL ended up being big. Not that big of a deal. It was still a really fast query because we had proper indexes. But then we realized that we wanted to have the questions on the front page as well for each guide. So we added the questions, and our include ended looking at something like this, right? We include user and questions, and the SQL at this point looks something like this, right? Still kind of big, but it's not too bad. It's still fast. We're still got our indexes. But the project evolved, and we realized that eventually we also wanted to display the authors of those questions on that front page, so they added another include for that. And questions also had answers, as I said before, so we added the answers. And answers also have authors, so we wanted to do this big, humongous include, and you end up with a SQL statement that looks kind of like this. All right. Now, as you can see where this might be leading, we ended up with a huge SQL statement, which was full of fail.
We're swimming in SQL. Oh yeah,
drowning in the SQL. Hey, wait a second! You got floaties on. You can't drown.
Well, I don't have a response to that.
Anyway, so obviously it was full of fail.
Now it's time to take the floaties off and fix the problem.
Yeah. Luckily with Rails 2.1, you don't always end up with these ugly SQL statements when you start abusing the include method. So if we go back to our first example where we have many guides that have a user and we do the include, with Rails 2.1, it actually does two queries. First it finds the guides, and then it finds all the users that belong to those guides. And it's much faster this way instead of doing the left join. Our next example, where we joined the questions model, if we take a look at the SQL that gets created here, it does 3 queries, and they're all pretty fast. That's pretty cool. Now if we take our last example that gave us our huge SQL statement full of fail almost drowned, if we take a look at the SQL that gets generated, it looks something like this. Now this is starting to get a little big, but when you really add up the time it takes to run all of these, it's still pretty low. And it's much cleaner this way. However, There is a catch here. If you need to add any conditions on any of these includes, it might not work. Here you see we added a condition on answers. But if you look closely at the queries, we didn't query the answers table until like the fourth one down. So that's not going to work because we only want to find the guides where we've got an answer with a specific user ID, right? And so what happens in this case, if you do conditions like this, you end up again drowning in SQL. More fail. Yeah. You might be wondering, how do memories work? Well, here you see a set of neurons and the synapses which connect them. One set of neurons might know what red is, another a round shape, another a particular texture, a particular smell, and maybe even a sweet taste. So, if I then show you a picture of an apple, these neurons all communicate with each other through their synapses to recall what an apple is. They're all connected. So now that you're thinking about an apple, I can ask you to think about what an apple tastes like, and it's not hard to make that connection. Everything is connected to everything else.
Well, that's interesting.
Yeah.
And tasty. But how does it relate to ActiveRecord?
An apple a day keeps the fail away.
Now I'm mad at you.
Hey. Our next challenge, we need to show the first 10 users and the number of posts they've created. Your code might end up looking something like this, where you get all the users, go through each of them, print out the first name and the count of posts they've created. Right? Your output might look like this, and if we look at the SQL statements, again we've got a lot of SQL statements going on. They're all repetitive. And on top of it, they take a while to run. So how can we fix this? Well, we can fix this by implementing a counter cache. Right. To do that, we simply add a column to our users table called post count, because we're going to keep track of all the posts a specific user has, and we're going to, in the post model, add belongs to user counter cache true. And this adds some functionality for you, which I'm going to show you in a minute. So first of all, if we create a new post, just like this, and take a look at the SQL list generated using the counter cache, this is what it looks like. First, the post gets inserted, and then at the bottom here it calls update users set post count +1. So it's incrementing the new counter. If we then go and we delete a post and look in the logs, it's going to call update post count -1. It's going to take one away from the count, and then it's going to delete that post. So you may be thinking to yourself, wait a second, if the delete fails, then my post count is going to be wrong, because the delete's coming after I update the counter. Now, this is what I thought to myself, and I ended up looking inside the ActiveRecord code, and it turns out that this is transactional. So if the delete fails, it's going to roll back the count. It's smart like that. So now let's go back to the original example where we're listing out the count of posts for each user. Now if we run it again, this time it doesn't do all those queries, it just gets the post count from the user table, right? And it's about 20 times faster. That's a pretty significant speed boost.
Now, most people, as they're going along and building their application, don't add the counter cache to start out with. So the question becomes, later in the game when you want to scale up your application a little bit, how do you go about adding the counter cache?
Yeah, it's a good question. You've got a couple different options. First of all, you of course run the migration, and then you've got two solutions. First of all, you can go through each of the users and call update counters on the post count column. However, if you have a lot of data in your database, this could be pretty darn slow. So the second option you've got is to just run some raw SQL, right? Which is basically doing a subselect in here. And it'll work fine. It'll be a lot quicker. Okay, it's time for a pop quiz.
Right.
I've wrote out my migration for my counter cache, and I'm ready to go, and it works. and then a week later, one of my developers decides to run all the migrations from scratch, and it fails on my migration. Do you know why that is?
Because you didn't fire the developer sooner.
No. Try again.
Well, I would have to say it's because you didn't reinitialize your class inside the migration.
Exactly. If you know a little bit about how ActiveRecord instantiates its models, as soon as you start using a model inside Rails or any application, it goes to the database and it says, okay, what columns are in my model? It then returns that column information and stores that inside the model. So all queries after that, where you're interacting with the model, it knows those columns. It doesn't reset those every time, because that'd be slow, right? So what's happening here, probably, why this is failing, is because you've got another migration that's already used the user model, right? It's already pulled the columns, and then when it gets around to this, and it tries to update the posts count, it says, oh, I don't have a post count column, so I'm going to error out. So to get around this, you've got two options, right? What would you do?
Well, personally, I would redeclare the user class in the migration.
Yeah, that's definitely one way to do it. Another way to do that is to use the reset column information function, right? Either way, and it'll reset the columns in that model, and you'll make sure that error never happens.
No fail there.
Hey. Before we move on from counter caching, I thought we'd take a quick look at the difference between the size method, the length method, and the count method.
So without the counter cache, if you do user.post.size, it's going to actually run a count query. If you do user.post.length, it's going to actually go through, pull all of the records, and then call length on the array that it gets out of there. Then if you do u.post.count, it will do the count query again.
Yeah. With the counter cache, post.size will use the cache as you would hope it would. With length, it does the same thing. It pulls all the records and then calls length on the array. And with count, of course, it does the count query. So you need to make sure, if you're using a counter cache, that you use the size method.
So what you're saying is size matters.
Yeah, I guess size does matter in this circumstance.
Huh. How about that?
Yeah.
Learn something new every day.
Yeah. Now we're going to go ahead and add a new column to our schema. We're going to add the published boolean, so we can figure out which posts have been published and which ones haven't. And what I want to do here is show the published posts from Greg. I might end up with code that looks something like this. Alright, find Greg, and then conditions user ID, publish, true, right? One way I can simplify this code is by using the proxy association. So I could find the user, and I could just do user.post.find. Lastly, I could probably do this all in one line if I really wanted to. Find the user and just get the posts. But more recently, with Rails 2.1, they came out with something called name scope. Some of you guys are probably already using it. We'll go into some more of the advanced features here, so hopefully you'll see something new. What this allows me to do is take this query and shorten it to just post.published. I can then do stuff like this as well, where I can do post.publish.find by title. So I can actually append find methods to the end of these scope methods, and it just adds the scope onto the find method. It's pretty convenient. So if we go back to our original problem where we want to find all the published posts from Greg, we can now just do get the user and do user.posts.published. And it's much more readable. I could also do this in one line if I wanted to. See here. Pretty neat. Now let's go ahead and add two more fields to the schema. We're going to add a created at field and an updated at field. With Rails 2.0, we can simplify this, of course, to just t.timestamps. Our objective here is to show the published posts from Greg in the last day. So what we could do is we could create another named scope, this one called in last day, which has conditions created at 1 day ago. We can then just call user.post.published.inLastDay. Well, this will work. This will work the first time, but it's going to kind of fail a little the next time we run it. What's happening is when our class gets instantiated, the name scope defines a new method on our class called inLastDay, right? And then every time I call that query, that same method gets called over and over again. Unfortunately, what this means is that if I ran publish.inLastDay, slept for 10 seconds, and ran it again, if I looked at my log file, this is what I would see. I would see that between the two queries, they have the same date and time. Interesting. So what that tells me is that 1 day ago is only getting called the first time and not the second time. To fix this, what we can do is simply add a lambda to our association. What that guarantees is that every time namescope gets called, a new date gets created. So if I run the same code that I ran a second ago, with this lambda, I'm going to see that each query is about 10 seconds apart, as it should be. What if, though, I want to create namescope with parameters? You can actually do this by sending in variables to the lambda. So if I wanted to find posts that were posted within a certain date, I could do something like this, which would allow me to call post.published.within 2 days ago, and I could find all the posts within 2 days. That's really readable code. You can do some really cool stuff with this. And here's the SQL that it would generate. Well, what if I want two parameters and I want to find all the posts that are published between 1 day ago and 1 month ago? What would that look like? Well, it's just as simple as you might imagine. We simply do a namescope with the lambda with two parameters, date, and I have older date in this case. And here's the SQL that gets generated. Lastly, I want to show you guys how you can do namescope with optional parameters. For example, maybe you want to pull all of the published recent posts and have that default to 2 weeks ago, but sometimes you might want to specify what recent means and send that in as well. To do that, what you do is you use the splat operator. So you can use splat args, and what that does, so hopefully some of you guys are familiar with it, it allows you to send in as many parameters as you want, and it'll just put them into an array. So in this case, I just use args first if I send in a parameter. Otherwise, I can specify what I want it to default to. So you might be wondering at this point, how do we create memories? Well, let's take a look at a newborn baby. When you're born, you have somewhat of a blank slate. The neurons don't connect to much of anything. So the first time a baby looks up and sees his mother's face, its brain stores what a face looks like by creating a series of neural pathways using both neurons and synapses, which we talked about earlier. Now, when a baby goes and sees his father for the first time, it doesn't quite do the same thing. It's not going to create a copy of what a face looks like. Rather, the baby takes the memory of its mother's face and uses this as a blueprint to find the differences. And this is sort of how memories are created. That's interesting.
Aw, baby's first diff. That's cute.
Oh, it's so adorable. Anyways, now we're going to be talking about polymorphic associations.
Which, if my math is correct, means many morphics.
Yeah.
Right?
Right. So when do you need a polymorphic association? Well, it usually starts out where you've got a single model. Let's say we've got a comments model, and a post has many comments. But then we build up our system and we start to add other models, and we realize we want to have those other models have comments. For example, maybe we want companies to have comments, and projects to have comments, and tasks to have comments, right? And soon enough, our model gets a little bloated, and our database ends up looking something like this, where we've got a bunch of different foreign keys, and that's just sort of sloppy. And you can find this with other sort of models, like maybe you like to tag a bunch of stuff, maybe you like to review a bunch of stuff, file uploads, ratings. These are all good examples of where you might want to use a polymorphic relationship. So, what does it look like? Well, we start out, with our ugly tables here. And what we want to do is make it polymorphic and end up with something that collapses all of those belongs to methods into just one. On the database side, we want to figure out something that collapses all of those foreign keys to just one, right? So we're going from 4 and 4 to 1 to 1-ish. And you'll see what I mean in just a second. So first, let's start out with the database layer, right? Here's our foreign keys, and if we looked inside the data, we might see something like this, right? Where we've got all these IDs associated with what models each comment belongs to. To make it polymorphic, well, the first thing that we do is we change the comments table to have a commentable ID and a commentable type. Now, when I first started looking at polymorphic relationships, this commentable keyword, I was like, is that a convention? If I make reviews polymorphic, is it then reviewable? If I make ratings polymorphic, is it then ratingsable? It doesn't really fit. But what it turns out to be is that that word there can be whatever you want it to be. It's completely up to you. So here I'm using commentable, right? The only thing that's required is that you have, your keyword.id, and it's an integer, and a keyword type, and it's a string, as you can see here. In our database, it ends up looking something like this, right? Where our ID refers to the foreign key of each of the models, and in our commentable type column, we have which class that foreign key refers to. In the model layer, what we end up doing is, on the comment model, belongs to commentable, there's that keyword again, polymorphic true. What this allows us to do is find all the comments. We could print out the comment bodies and the class of the commentable association if we wanted to, and the title of that model. What we end up with is something that looks like this. So if we take a look at data again and kind of compare the results, we can see that it's looking at the commentable type column and properly casting to the proper model. Here, you can see it casting to the post model, company model, task model, and project model. It's pretty smart that way. If we look at the other side of the model relationship, for instance, if we look inside project, project has many comments. As commentable, there's the keyword again. This would allow us to run code that looks something like this, where we get a certain project, go through all the comments in the project, and simply print them out. If we had one project, it would just look like this. And what's interesting is we look inside the database to see what's going on. You can see that it's properly calling select star from comments, where commentable ID equals 2 and commentable type equals project. It's specifying the class here. If you like this functionality and you want to add comments in a polymorphic way to your application, you don't necessarily have to use this code. There's a plugin that already exists called Access Commentable, which does this already in a polymorphic way. It's time for another pop quiz. Are you ready, Jason?
Ready.
Okay. What is missing from this migration?
That would be the index.
You are correct. Even if you're using polymorphic relationships, you still need to remember to add an index. If you get big polymorphic tables and you don't have an index, they can start running really, really slow. So you need to make sure you have that. So how does forgetting memories work? Well, if Greg and Jason were to hand you a new ActiveRecord function which you had never seen before, and maybe it was related to foreign keys, email, validation, your brain would form a new neural grouping which would become the memory, right? That's how we create memories. Of course, each of these other memories is linked to a bunch of others, right? But what would cause us to forget this initial function? Well, what happens is over time, if you don't use the memory, the synapses which connect them start to get smaller and smaller and weaker until eventually they just disappear. And then you forget the memory. And that's how we forget.
So what That saying is, if you don't use it, you lose it. No?
Yeah, I guess so.
Nice.
Yeah. So as you can see here, next up we're talking about single table inheritance. With single table inheritance, we're going to be using a different schema. As you can see here, we've got songs, videos, and photos. Each of these has a model. They all belongs to user, except they all have different methods in each model. You can amplify a song, you can trim a video, and you can crop a photo. And if I was interfacing with these, I could do some statements like you see here. So what's common here, obviously, is that they all have the same database fields. So how do I then use single table inheritance to simplify this scenario? Well, first on the database layer, I take all of these tables and I combine them into one media files table, which has the same column except for one, which is the type column. Right? And if you're remembering back to polymorphic associations, it'll look familiar when you take a look at what the database might look like. All right, so we've got our file path, our user ID, and the type here is again representing the class. Right. On the model layer for single table inheritance, it looks something like this. We have create a new model called media file, and this belongs to user. We can also add functions in here. And each of our media types, song, video, and photo, inherit from this model. So they all inherit, they all now belongs to user. They all have that download method, but they also have their unique methods, amplify, trim, and crop. Well, let's go ahead and figure out how we might retrieve a user's media files. Well, if we look inside the user RB, we've got now has many media files. We can then fetch a user, go through each of the user's media files and print them out, and print the class just to make sure that the type is working as we expect it to. We'd end up maybe with this sort of output. So you can see here, it's using the type column to cast into the right model. What if we wanted to get just the user's songs? And could we write something like this? Would this work if we just did user.songs? Well, no, that's going to error out. So what do we have to add then to be able to do that? Well, all we have to do is add has many songs, and that will properly pull just the songs, which is interesting. When I saw this, I was like, that's all there is to it. So I went and I looked in the database log file, and as you can see there, it's just pulling user ID equals 1, media type equals song, like you would hope it would. How would we then create a new song? Well, there's two different methods. Firstly, we could create a new song model and then add it onto the media files array. Secondly, we could just do user.songs.create, and that would work too. However, if we did that, we would definitely have to have the has many songs in the model. The last topic we're going to cover real quick is taking a look at some of the new hotness for ActiveRecord in Rails 2.1. First of all, it's pretty simple, and some of you guys are probably already using it. Instead of user.findAll, you can do user.all. Instead of user.findFirst, you can do user.first. And you can also do user.last. So if we had a function like this, where we pull the guide number 6, and get all the questions and get the last question. Before Rails 2.1, this would actually fetch all of the questions and then just call last on the array, which is, a little more data that you're pulling more data than you want to. But with 2.1, it properly limits the query so that it only pulls the last question without pulling all the questions, as you would hope for. Lastly, we're going to briefly touch on dirty objects.
Greg, you're always trying to touch on dirty objects.
Hey, how would you know?
Saw your browser history.
Oh, lies. Anyways, what dirty objects allows you to do is check and see what's been changed with an object. So if I change the title I can detect if it's been changed. I can even pull up what it was changed from. I can get all the changes in an array, or I can even get all the changes that happen to a model in a hash, which is pretty convenient. And this leads us to another feature, which we can now do because we're keeping track of that. You see, this query up here, right? All we're doing is we're changing the title. Before Rails 2.1, if we then, save this, it's going to run update, and it's going to send in all of the different columns, even if we didn't change it. I mean, this body attribute here is huge, and we're sending it in our update method. It doesn't make any sense. But now that we're keeping track of what gets changed, we can just do a short update and send in what needs to be updated. Of course, if you don't want to use partial updates, you can always turn that off just by using this line in your environment.rb. There's one gotcha I want to go over with partial updates, though, that I ran into the other day. If you run either of these queries and you've got partial updates turned on, nothing is going to get saved to the database. Nothing at all. If you're using any bang operator to change a field, or if you're using the in-place edit. Right? Why is this? Well, it has to do with how dirty objects are implemented. Basically, it's looking at the attribute equals method, right? When that gets changed, then something gets flagged as dirty. But if you're using one of these, it goes around that. So what you have to do, if you still want to use these partial updates, is call the field.willChange! And that tells the model that this field is going to change, even though it might not normally get record of it. Well, that wraps up the first advanced ActiveRecord Envycast. In conclusion, just to go over what we learned, don't forget to use indexes, use but don't abuse includes, use counter fields where needed, use name scope because, man, you saw that. I mean, you can create some amazing readable code with it. Use polymorphic associations and single table inheritance where you need. And lastly, if you can, upgrade to Rails 2.1 because there's some really great stuff you can use in there with ActiveRecord, and I highly recommend it.
We really hope you enjoyed the first Envycast on Advanced ActiveRecord. If you'd like to learn some even more advanced ActiveRecord, stay tuned for the next part in the series. We'll go over how to create plugins with ActiveRecord, how to create gems, go over all of ActiveRecord's events and callbacks, observers, and much more. Thanks again.
Yeah, thanks for watching. See you guys later.